Hi guys, Miss Griffin. We're looking at Unit 8, Skill 4, Logarithms and Exponential Form. So our essential question right here says, how do we switch from exponent form to log form? So sorry about this messy handwriting. That says log and this says form. How do we switch from exponent form to log form and back? And what are logs? They are not your campfire logs. We're not talking about those. Look at my artistic skills right there, right? Just kidding. So first things first, we're going to talk about inverses of a function, and this should say inverse, not inverse I. Sorry about that typo. How do you find the inverse of a function? So remember, when you're asked to find inverse, all you do is simply switch x and y. So we've got this function, y equals 2 to the x, and we're asked what would the inverse look like. So first we're going to do the normal function itself. So this is just going to be the y equals 2 to the x power. So I'm going to fill this table in. X's are just normal. You know that 2 squared will become 4, and 1 square, or 2 to the first would become just 2. 2 to the 0 would be a 1. Then if you need to, you can use a calculator, but 2 to the negative first is 1 over 2 to the first power, or just 1 over 2. 2 to the negative second, if you think back to your exponents, that would drop the 2 down, but it would be to the second power, so that's really 2 to the second, which is 4, so 1/4, and this would be 1/8. If we want, we could put in a 3 down here. That would give you 2 to the third, which is just 8. Now, you could have used a table in your calculator to do that, but since we are all mathematicians here, we can do that in our heads. So go ahead and plot this. So pause and plot. So I've got mine plotted. I noticed that it's getting really close to 0 as we go to negative infinity on x's, but it's never going to hit 0. So that's like an asymptote. And then we're looking at the inverse. So now we're going to switch x and y. So you see how this x value got switched over to the y value? That means the y value now becomes the x value. So I'm going to fill in the y's because that's the easy part right now. And then the x's move to the y's, so the y's switch to the x's. So this is 1/4, 1/2, 1, 2, 4, and 8. So pause and plot, and then we'll see what this looks like here. So now that we have that plotted, we can see that these two functions are inverses, again, because not only did we switch x and y, but also remember that an inverse is reflected over y equals x. Inverse is a reflection over y equals x. And that's that line that goes through the origin with a slope of 1. So the inverse equation would look like this, right? We switch x and y equals 2 to the y power. Now, we normally want to get this back in y equals, but we're struggling because how do you get rid of y as a power? So now we're going to introduce these things called logarithms. And we shorten it by just using the word log. And again, it's not the kind that you build a fire with. So a log is an exponent. That's all it is. A log is a special exponent that allows us to get y equals from the equation above. So any exponential in the form of a base raised to an exponent equals some number. So let me again just describe what those things mean. Where'd my pen go? Base to an exponent equals some number. So we've got big B means base. The E means exponent. And N just means some number. So anytime you see something written in that form, it can be rewritten as log base B of N equals E. So what just happened is we took Ben form and changed it into Benny form. Get it? Ben Benny. Okay, so there's a trick for this. We'll talk about the trick in a minute. So what we're saying above is that this equation of x equals 2 to the y can change forms. So this is our base, our exponent, and our number. So this means that we have log base 2 of our number x is equal to y. So that's the equation of this purple graph on here. So I just changed forms using that Ben to Benny base number exponent. So it says, what kind of numbers can we take the log of? Well, you can only take the log of positive numbers. And we have a special sort of log, and it's called a natural log. So I'm going to write ln equals natural log. And a natural log has base e. E is just a number. If you type in e on your calculator, you know how you have like x to some number? Well, you can type in e to some number. And if you just type in e, that gives you e is equivalent to 2.71828. And it keeps going. It's a never-ending decimal, non-terminating. So just like, pi is 3.1415, blah, 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 e is also a number. So instead of writing out this value every time, we just write e. So in a log, the normal base is 10. In a natural log, the normal base is e. Okay, so we'll see more with that later, but I just want you to understand again that here, a log is an exponent that helps us go from exponential form into logarithmic form. Okay, so flip it over and we'll see a little bit more with this. So here it says, sketch the following and then make a table for each graph and also answer these questions. So first we have to graph f of x equals 3 to the x. And then secondly, we have to graph f of x equals log base 3 of x. So we again know that first we can make a table for f of x equals 3 to the x. Right, we can start at negative 2, negative 1, 0, 1, 2, 3. You can use your calculator if you want to, but this is, again, very basic. 3 to the third is 27. 3 to the second is 9. 3 to the first is 3. 3 to the 0 is 1. Then we just reverse that in terms of reciprocals, because this would be 3 to the negative 2, which is 1 over 9. So we can graph that. So if you want to pause, you can. I'm just going to keep the video running because I'm being a little lazy. Over 2 up 9 is the first thing that can fit. Over 1 up 3, 0, 1, negative 1, 1/3, and then negative 2, 1/9. And I'm going to label this with f of x equals 3 to the x. Then, in order to graph this log base 3 of x, we could use our calculator, but we know that f of x, I don't know why this zoom keeps changing, I'm sorry about that. F of x equals 3 to the x, and f of x equals log base 3 of x are inverses. So now to make my table for log base 3 of x, all I have to do is switch x and y. So that negative 2 now comes here. All my x's switch over to the output, the y's, and then my outputs now switch to inputs. And then we can graph that. So I'm going to start with 1, 0. That's the easiest for me. And then 3, 1, 9, 2. And then I can get these fractions in here. 1/3 is at negative 1. 1/9 is at negative 2. And this is f of x equals log base 3 of x. So then the next thing we have to do is answer these three questions. Find the domain range, find the x and y intercepts, and what is the equation of the asymptote line for each. So I'm going to split this graph so that, or the space on the bottom, so that I can have an answer to each of these questions for both equations. So I'm going to write f of x equals 3 to the x here, and f of x equals log base 3 of x. So you can have whatever base you want in here, but I was just saying earlier on the other page that the common base is 10. So if there's no base written, then you are to assume that it's a 10. So here, part A, we need the domain and the range for each one. So remember that domain goes from negative x to positive x. So the smallest that this will go in terms of x's looks like negative infinity for the green graph. And then to the right, in terms of x's, well, it can go on forever. So that's positive infinity. As I mentioned on the previous page, the range, this graph will go no lower than 0. So 0, comma, up to infinity. It can grow as much as it wants. And then for the log graph, the blue graph, domain, well, it looks like it's going, and it's never going to get close to 0. But it can go to the right forever. So that's infinity. And then the range goes from negative infinity as low as possible up to positive infinity. It's just going to grow pretty slowly. So if you, again, notice what happened here, the domain and the range switch spots. And that's got to be true because these are inverses, so again, we switch x and y. Part B says find the x and y intercepts, excuse me. So part B, x-intercept, y-intercept. And we have to do this for each one. So x-intercept for the green graph. Well, it doesn't cross the x-axis, so that's not applicable. The y-intercept, though, however, is 0, 1. Then you can imagine that these would switch spots, sort of, in terms of whether or not we have an intercept. So x-intercept is at 1, 0. Y-intercept is not applicable. So, of course, when we switch from the x-intercept or the y-intercept to the x-intercept, the coordinates also have to switch because we're switching x and y. But again, take notice that because they're inverses, the same rule applies with switching. And then part C says that we want the asymptotes. So the asymptote for the green function, if I zoom out a little, we can see it all together. We said the asymptote for the green function would be a horizontal asymptote at y equals 0. For the blue function, this one would be a vertical asymptote at x equals 0, because x will never become 0. It'll get really, really close, but won't actually hit it. Okay, flip it over and we're going to talk about how to change forms. This is the fun part to me. Next page. All right, so now we're going to talk about how to change from Ben form to Benny form. And so there are two tricks that I have. Mr. Rogers has another, and so I'll tell them all to you, and then you can decide what you like best. So when we're changing from, let's start with log form, right? So when we start with log form and we have to switch, I use something called the loop method. So when I loop, what happens is that we have the base raised to the exponent equal to the number. And you can see right here in Ben form, it's base raised to the exponent equals to the number. So I'm going to write this trick off to the side, and I would suggest that you do the same. So if we have log base number equals exponent, and we loop it, then that gives us, I'm just going to write loop method, then that gives us base to the exponent equals n, right? I just go in the order in which I see it as I hit each part. I start with the base, raise to the e, because that's what I hit next with my loop, and then equals to the n. Okay, now Mr. Rogers has a simple trick. The base, whatever that base was, has to stay the base, and then you switch the other two. So I'll write that down. Base stays base, switch the other two. Ooh, I don't want a highlighter. Base stays base, switch the other two. So this applies not only to when we switch from logs to exponential form, but also in the reverse. Okay, so Roger's trick works both ways. Then I've got a different trick to switch from bend form into log form. So for this, we would make an L because we're switching into log form, L for log. So we write literally log. Then I hit the base first. So base goes in the basement. And then as I follow this log around, I hit n. So of n equals the last thing, in other words, the exponent. So as Rogers had said, you can use base stays base, switch the other two, because the base stayed the base and went down to the basement, and then the e and the n switch spots. Okay, so both two tricks, either works. Doesn't matter to me which one you use, as long as you know how to change forms. So I'll show you both ways here. If I do the L method, I've got to write log. That base of 3 is what I hit first. And then I keep going around, and I have of 9 equals 2. Okay. Then if I wanted to do it the other way with Roger's way, it's the same exact thing. This base of 3 stays the base, and then I literally switch the 2 and the 9. Okay, writing that log word out. We'll do another one together. So if I use my L method, then we have log base 5, because that's what I hit first, of the number 125, that is, equals whatever I have last, -3. And again, Roger's method says base stays base, switch the other two. Okay, go ahead and try the next one on your own right here. So you should have had log base 8 of 4 equals 2/3. For this next one, you'll notice that the base is an e, and so what we're going to use is not just log, but the natural log. Base e of 6 equals x. And I'm going to apply the same type of thing down here to the last one, even though it's an x here. But it's an x as the base, so I'm going to use the regular log. Base x of 6 equals 5/3. And again, if you're following along with the L method, all you do is trace it around. I start with the x, because that's what comes first. I move over to the 6, and then equals 5/3. Now, if this had been reversed, 6 equals x to the 5/3, and you're like, oh, I don't know how to use my L. Well, guess what? You can just switch the equation back around to this form, and you're okay. Or think about base stays base, switch the other two. Okay? Now, if we're switching from logs to exponential form, you can do your loop method, or you can do base stays base, switch the other two. It's up to you. Both work in the same exact way. So for me, loop method tells me 6 raised to the second equals 36. Base stays base method tells me the same thing. Base of 6 stays the base of 6. Then switch the order of these two. Okay? Loop method here tells me that 4 to the -3rd equals 1/64. And you could even test that in your calculator, right? Type it in. Test it. See if 4 to the negative third is 1 over 64. Go ahead and try the third one right here that I just boxed in. You should have found 3 to the fourth equals 81. This next one, it doesn't have a base, but it is the natural log, so that means the base is an e. So base stays base tells me e, then switch the other two. E to the b equals a. E to the b equals a. And then here I've got base of x, switch the other two. And again, this is Ben form because we have base raised to an exponent equals n. The other one is Benny form because it's log of some base to the n, or of the n equals e, that exponent. All right, make sure that you practice this on your practice packet. You do have to successfully switch forms both in your CFU and in the future, so practice. If I could spell, that would be fantastic. All right, have a good day.